Hey guys, I'm Mr. Santos again. Today we're going to work on forces. Okay, so go ahead and get ready. So, force, what is force? Okay, force is basically a push or a pull. Okay, so I'll give you an example. I have this block right here, right? If I apply force to this side, okay, that's a push. When I do it the opposite side towards me, that's a pull. So a push or a pull is basically what force is. So that's the most simple definition that I can give you, okay, guys? Push, pull. That's what force is. All right, so moving on. How can we measure force? Okay, we can measure force with different tools. So, for example, this right here. Do you know what this tool is? Okay, guys, so if you do not know what this tool is, go ahead and, if you do know, go ahead and type it in the chat. If you don't know, then it's okay. All right, so what this is a spring scale, okay? It is called a spring scale because it has a spring inside, okay? So it is a spring scale. We use this to measure force, okay? Depending on how much force you use, it gives you a different type of reading. So let's go ahead and measure some force. I have two different types of bottles. A bottle that has a lot of sand in it and a bottle that has not as much sand in it, okay? So we're gonna see which one requires more force to be able to pull it up in the air, okay? So I'm gonna go ahead and grab and do the small one first. Okay, so I'm gonna pull it with my spring scale, and it says I have 1 Newton. Okay, so I need 1 Newton of force to pick this up. Okay, so that's how I measure the force. Now, do you think this picking this up is gonna require more force or less force? All right, so let's test it out. Oh, wow, look at that. It definitely requires more force, okay? It's about 2.1, 2.25. So this is 2.25 newtons, okay? So it definitely does require more force, right? All right, here we go. So the more force you require, the more the string stretches, or the spring stretches, okay? I don't know if you ever went to the grocery store before, and you put something on a scale to see how much it weighs. Okay, so like for example, if you want to see how much the bananas weigh, you put it on a little pan. There's like a little pan on there, and it shows you how much it weighs. That's basically what it is. That's basically what a spring scale is, okay? And we use this for that. All right. Next, we're gonna go ahead and let me go ahead and change my camera here. See if I can move it downwards a little bit. There we go. Oh, almost fell. Okay, so what we're gonna do is we're gonna test how much force is required to do different things. So for example, I'm gonna go back to my blocks, okay? And then I'm gonna set up a little tug of war line here, okay? All right, so this tug of war line is going to see which one has more force, or which one applies more force when being pushed together. So when I push them together, which one do you think will apply the most force, okay? So before we do that, I'm gonna go ahead and set them in this pan balance, okay? I wanna see which one has more mass. Do you think the different amount of mass is going to affect how the force is? Let's see. So let's see which one has the most mass. All right, so you can definitely see that the little pin right here is pointing to the opposite side. So because this is heavier, this one goes up. When I try to pull it down, it continues to go back up. That means that this is definitely has more mass, okay? So now that we know, okay, now that we know which one has more mass, now let's test them out. I'm gonna put them into a crash test. They're basically going to crash in this line right here in the middle. Now, if this one applies more force, then we should see this come this way. The little smaller block move this way. If this block has more force, then we should see the bigger block go this way. So whoever has the most force is gonna be the one that chooses which side to go, okay? So go ahead and tell me, which one do you think has the most force whenever they're pushed together? All right, so let's go ahead and test it out. We're gonna do it 3 times. Remember, we must do it multiple times to get an accurate reading. The more times you do it, the better the reading it is. Okay, so let's do it in 3, 2, 1. Okay, so what happened? We noticed that this one pushed this one. Let's try it again. Trial number 2 in 3, 2, 1. Okay, and once again, we see the bigger block pushing the smaller block that way. Last trial, 3, 2, 1, and once more, okay? So we did do it 3 times, and in all 3 times, the bigger block, when pushed together, it has more force. Therefore, it pushes the block to the other side, okay? Very good. All right, so you basically can see this like whenever you're driving, and then whenever whenever there's different cars going at different speed, the bigger car is gonna go much faster. The bigger car is definitely gonna go have more momentum. So whenever it tries to slow down, it's gonna be harder to slow down because it has more mass to slow down. And then whenever there's a down slope, whenever you're going down like a bridge, you require more energy to slow down on the bigger block than you do for the little one. Okay, so we're gonna go ahead and do one more experiment, and I'm gonna go ahead and take this camera to do the other experiment. The other experiment is basically a little testing down a ramp. So let me set up the camera real quick. All right. So what's going to happen is that we're going to go down this ramp. Oh, sorry. Let me adjust the camera real quick. All right. We're going to have 3 different tools, 3 different objects. I'm going to drop 3 different marbles down this ramp. It's going to travel down the ramp, and it's going to hit this block. Now, when it hits this block, it's going to lose energy. Remember, whenever the 2 blocks crashed, the little one lost a lot of energy, and the bigger one was the one that pushed it away, right? So the ball is going to lose energy, and we're going to see how far it travels, okay? So we're going to see how far it travels once it goes down the ramp. We're going to set up either here, here, okay? Depending on how far it travels, that's what we're going to see, okay? Let me see if I can get a good angle of this right here. All right, I believe that's a good angle. That way you can see how far the ball will travel, okay? We are gonna use 3 different balls. They are about the same size, okay? They are pretty much about the same size. This one is a glass marble. So a glass marble has a different mass than the other ones. This one's a plastic ball. It also has a different mass. And this one is a steel ball. So out of the 3, which one do you think has the most mass? Out of the three, which one do you think has the most mass? Okay, so let's see. We're gonna go ahead and place them into our pan balance, and we're gonna see which one has the most mass. So right now it's balanced, and let's try a steel ball and a glass marble. Okay. All right, so the steel ball definitely pushed down. Look, you see how it keeps going down? That means that the steel ball has more mass. Okay, now let's try the glass marble and the plastic ball. Which one do you think has the most mass? All right, so this time the glass marble has more mass. Okay, notice that it keeps going down. So if we were to put them in order, how would you put them in order from greatest mass to least mass? I'll give you a second to think about that. Very good. The steel ball has the most mass, followed by glass marble, and finally the one with the least mass is the plastic ball. So I want you to predict, I want you to think, which one do you think will travel the furthest? The one with the most mass, the one with the least mass, the one with the medium size mass? So once I roll it down the ramp, it's gonna hit this block, and we're gonna see which one will travel the furthest, okay? All right. In order to help us do that, we're going to label them. So steel is going to be yellow, and I'm going to use these little yellow markers whenever they pass by. Glass is going to be blue, and plastic is going to be pink, okay? All right, so let's go ahead and test them out. Let's start with, I guess, plastic. Let's see. In 3, 2, 1. I'm sorry. 3, 2, 1. All right, so it landed about right here, okay? Let's see. Now, in order for it to get accurate reading, we have to do it 3 times or more. So I'm going to do it again so that we can get a better reading, okay? In 3, 2, 1. All right, so this one went about right here. Okay, that one did push a little bit more, okay? And let's do it one more time. In 3, 2, 1. All right, and this one went pretty similar. It went about right here. So we can say that this one is kind of like not so true, okay? This 2 makes more sense. So if I was to do it again, if I was to try it one more time, I'm sure that it's more likely that the ball would travel over here versus all the way over here, okay? So let's go ahead and move to the next ball. The next one we have, we're gonna go ahead and do the steel ball, okay? Let's see how far the steel ball travels. 3, 2, 1. All right, so the steel ball traveled all the way over here. Let's do it again. 3, 2, 1. Oh, I got stuck. And it traveled all the way over here. Okay, so let me get a marker so that we can put it right there. So the steel balls definitely seem to travel a little bit further, okay? Let's do it one more time. And, okay, that was pretty accurate. So the third one kind of landed right there, okay? All right, so we're gonna do one more, which is the glass marble. Okay, where do you think the glass marble will land? Okay. Okay, where is it gonna go all the way to the end of the table? Is it gonna go towards the middle? Is it gonna go towards the beginning? Okay, so you guys tell me, where do you think the marble is going to land? Okay, here we go. In 3, 2, 1. All right, so it went right here in the middle. Okay, so we're gonna put a marker on there, and that's where it traveled. Okay, we're gonna do it 2 more times. Okay, and it traveled right about here, kind of close to the top of the other one. And finally, all right, in between these two. Okay. So here we have the markers. Let me go ahead and take the camera over there so you guys can see where the markers kind of landed, okay? And do one more down. There we go. All right, so again, the ball went down the ramp, hit the block, and then landed this way. Okay. What does this mean, guys? What does this mean? Remember, the yellow ball traveled the furthest, which is the steel ball. Okay? Followed by the glass marble. And then, of course, we had a bad reading, which we can probably remove this one, and we can say that the plastic landed on this side, okay? That makes a little bit more sense, right? Okay, so the metal ball traveled the furthest, followed by the glass marble, followed by the plastic ball. Do you think mass has anything to do with this? How can you relate mass of the object to the distance the ball traveled? Okay. All right, guys. So that's everything I have for you today. Let me go ahead and get down here. All right, that's everything I got for you today, guys. Thank you so much for watching. I'll make sure we get to do another science lab next week. Okay. Bye, guys. You have a good one.